you. All day long today we're going to be talking about linear equations and linear functions. So right now we have a ferry boat. Okay, if you've ever been on a ferry boat, you'll know that there's cars that go on the ferry boat. Thank you for not talking while I'm talking. I appreciate that. So, yeah. So right now we have a ferry boat right here. This is the ferry boat. Okay, that's the ferry boat. And on the ferry boat, what are there going to be? People and cars. Okay, so here's what I want you guys to write down. Okay, put F of C equals the number of ferry boat trips. Okay, that's the number of ferry boat trips. Okay, now what goes on the ferry boat? People and cars. Okay, and so right now what I'd like you to do is I'd like to write C equals the number of cars that go on the ferry boat. Okay, those are the F of C is the number of trips, C is the number of cars. Now it gives us a function right here. Here's the function. It says the number of trips that a ferry boat can take is equal to the number of cars that go over the number 20. What do you think that 20 represents?
20 times.
20 times? This is C divided by 20. And what is, by the way, what is F of C equal? The number of
Cars.
the number of ferry boat trips. C is the number of cars. F of C is the number of ferry boat trips. So how many cars do you think can fit on a ferry boat at one time? What's the maximum that fits on the ferry boat at one time? 20. That's how many cars can fit on this ferry boat. I know it's kind of hard to count. You can't really see them all. Okay, there's a car there. But there's a total of 20 cars per trip. Okay? So right now, it says, if there are no more than 5,000 cars transported every single day, what is the key word? It's kind of hard to see. I'll erase this part right here so you can see it. What are you looking for?
Range of function for this situation.
We're looking for the range. So everybody, that's pretty key. We're looking for the range. So I'd like us to make a little table here, okay? Let's make a table. We'll call this C, and we'll call this F of C. Now, all of these numbers right here, these are going to represent what's called the domain. All right? And all of these numbers that I'm going to create over here represent the range. Technology is great when it works. So here's the domain, here's the range. This is the input, this is the output. Okay? Technically, how many cars have to go on the ferry boat? No. 0, right? Technically, now it fits up to 20. Okay, it fits up to 20 on the boat. Short for ferry boat. So it fits up to 20 cars. So if I have 0 cars, how many trips do I have to make? 0 trips. Now there was a maximum. Ooh, it says there's not going to be any more than what? 5,000 cars. So where am I going to put 5,000? Here, on the left or on the right?
Left.
All right, so we'll put 5,000. So right here, you're going to put, I saw a lot of people do this. It's good. It's perfect. It's exactly what I wanted you to do. You put 5,000 over 20, and what did that end up equaling for you? 250. All right? Which means right here, 250. Now, everybody, let's interpret what this means. The amount of cars that can go in one day, not just on one ferry boat, but on one day, the amount of cars that can go is a total from 0 to 5,000. That's the domain. So everybody, for answer choice B, I want you guys to write. That answer represents the domain. Okay? All the integers Remember, integers don't include fractions. You can have 0, 1, 2, 3, 4, 5. All that is not a fraction. I mean, technically, I know 5 divided by 1 is a fraction. But all integers aren't fractions, okay? From 0 to 250, that's the range. Okay? So in this particular case, the answer is D, because it asked us for the what? It said find the range of the function. Okay? If I did the exact same question and just changed this one word, says what is the domain of the function, then the answer would be answer choice D. Okay? These answers A and C are the ridiculous answers that have nothing to do with anything being reasonable. By the way, this is the student expectation you're expected to know. It says what? Determine the domain and range of a linear function in mathematical problems. Determine reasonable domain and range values in real-world situations. Okay? So this was a real-world situation where you had to figure out the range. All right, everybody, what we're going to be doing right now is we're going to be practicing domain and range before we practice slope the rest of the day. Okay, so here we go. We have a line, an equation that goes just to the right. It says write the domain and the range for all the graphs below. So we're going to write the domain and the range. Okay? So right now, I'm going to choose blue for domain. I'm going to choose red for range. Okay? So we're going to do blue for domain and red for range. So right now, I'm going to go straight down. That lets me know where I get to start the graph. Okay? Over here, this lets me know where I am on the y-axis. So this gives me a hint for the range, and this gives me a hint for the domain. Okay, so I'm going to do this one with you. And I'm going to give you guys an opportunity to do one on your own. So here we go. Right now, this says domain. Where am I starting? I'm starting at a positive 7. So I know my domain's at a 7. But you guys see that open? It's open, right? Which means it doesn't include the 7. My domain, is it getting bigger than the 7 or is it getting less than the 7? Bigger. Bigger. So your x values are greater than 7. So that's the answer right there. X is greater than 7. Right here, where are my y values equal to every single point? What are my y values equal to right here? 3. Right, the range is y equals 3. Where's my y value? Right there, right there, right there, right there. Going forever, my y value is always going to be equal to a 3. It's not getting bigger, it's not getting smaller, it's staying right there. That is the answer for answer choice A. Going over here, I'm going to do the same strategy, except I'm going to let you guys come up with your answer. Right now, I will not sharpen your pencil because I'm still working. When I pause the video, then I will sharpen your pencil. I'm going to give you a hint what I did. I'm not going to give you the answer. I'm going to pause the video. This right here gives you a clue for the domain. This right here gives you a clue for what the range is going to be. You could use twistables if you want. So this right here gives you a clue of where your domain starts. This right here gives you a clue of where your range is on the y-axis. Okay? So I want you guys to come up with 2 answers. I'm going to pause the video. All right? And then you guys are going to come up with those 2 answers. So if we look at our graph right here. Okay? Our graph starts right there. What's happening with all of my x values? What's happening? They're going to the right. Well, where am I starting at? On the x-axis. No, not on the y-axis. On the x-axis. Starting at 0, right? So I'm starting at 0. What's happening to all of my x values at 0? Is it equal to 0? No. No? But it's definitely going what? It's going to the right. So all of my x values are greater than 0. All of my x values are greater than 0. So right here I'm going to write x is greater than 0. Okay, x is greater than 0. Now, what happens if I would have filled in that dot right there?
It would be
Greater than or equal. Then you would see a symbol greater than or equal to. Okay, but we didn't have that. It was open, right? So range. My range is where it's on the y-axis. Is that going up or down on the y-axis? No. Where is it at the whole time? Say it again. Positive. I know it's kind of hard to see. That's 1, 2, 3, 4, 5, 6. You're at a 7, so your y values are all equal to a 7.
But that thing's just circled though, it's not filled in.
But it's equal to a 7 anywhere else also.
So your circle's just circled, it's not. Does that have anything to do with it?
It would be if there weren't a line going forever to the right. Okay? So being that this is a circle, is the y value equal to 7 right there? No, but is it equal to y is 7 there and there and there going on forever? Okay? So let me show you guys what a graph would look like. If
The circle part really didn't pertain to the y at all. It was more with your domain.
So right here, if I had a circle right there, and I didn't have anything, right now I don't have anything to graph at all. Right now you can't even say
it's really not even a point.
It's not even a point.
It doesn't have a line.
It doesn't tell us where it's going. If I would have said, if I had a line going this way, then my answer for this one would be x is less than, where is it starting, but not quite, -5. But what is my y value still equal to right here? Still equal to a, not a negative, a 7. All right, -7 is down here. All right, so there we go. Now we're going from a horizontal line. These are horizontal lines, which have, by the way, horizontal lines, what do they have this slope on? 0, very good. Now we're going to be going over here to vertical lines. What do vertical lines always have a slope of? Nope. Undefined. You can't define it. Okay? Don't worry, we'll be going over this. All right, so here we go. I'm going to help you guys with this one, so you guys do the next one on your own. Okay? So we have a vertical line. I'm going to shade. D, here's my domain, that's going to be blue. My range is going to be red. So let's look right here. The domain, that's where the graph is, right there. That's my domain. That's my x, that's where all of my x values are equal to. What is my x value at every single, not except for that one, what are my x values all the way down? At what? No. 7. What's my x value here? Here. All the way down. So my x value is always equal to the number 7. That's my domain. Now the range deals with my y values, right? So right here, this section is called the range of the graph. So what is my minimum value? Not minimum. Maximum, sorry. What's my maximum value and what's my minimum value? What would we say my minimum is going towards? Negative infinity, right? So my minimum is negative. It goes on forever, all right? Eventually it's going to say hi to thing. Now, maximum. What's the highest that this graph gets but doesn't quite touch on the y-axis? 0. So my maximum is approaching. My maximum is approaching 0 but doesn't quite hit it. So what are all of my y values? Are they getting bigger than 0 or are they getting less than 0? Less than 0. Come on, board, wake up. Nope. Try one more time. Nope. There we go. All of my y values are less than 0. Now if I were to put a solid dot right there, that doesn't change, that does not impact my domain, but it does impact my range. Then I'd have to put a equal to sign right underneath. Okay? So those are my two answers. Here we go. For those of you watching the video, pause it and see if you guys can get the answer before I do. Alright, when we do this, one thing I always try to do is I start where my point is, wherever I am. Alright, I'm going to draw a blue line down to the x-axis that helps me with my domain. And then I'm going to draw a line going to my y-axis that helps me with my range. Okay? So if we look at our domain, does this line change from left to right? No, it stays the same, right? Where am I always at on the x-axis? 7. So let's say my x value is always equal to the number 7. Okay? However, if you look at our range, what's happening to all of my y values? They're not staying the same. They're going up. And where do I start at? I start at a positive 7. So all of my y values are becoming greater than a 7. Those are two answers. Okay? All right, what we're going to do right now, everybody, I need you guys we got to work hard. Okay, we're going to be working on practicing slope. Okay, I'm going to take a screenshot of this real quick. These are all the problems that we're going to be doing in your journal. What I want you guys to do with me, just do them one at a time. Don't write them down all at once. I want you guys to write down problem number 1 in your journal. We're going to be finding the change in the y over the change in the x. So I want you guys to practice this with me. This is going to be one of your assignments that you're going to be doing online on Khan Academy. I want you guys to practice before you guys do that assignment. So we're going to go ahead and start with problem number 1. We're going to find the change in the y over the change in the x. So here we go. Problem number 1. Follow along with me. We're going to label this x1 and y1 and x2 and y2. I'll move out of the way. Here we go. All right? That's the first thing I want you to do. So label your ordered pairs. Okay? Once you label your ordered pairs, then, and only then, I want you to set things up exactly as I do. It's very important that you organize your information. We're going to find the slope of the line that passes through a 4 and a 5 and a 2 and a 7. We're going to call this y2 minus y1 over x2 minus x1. What's my y2 value, everybody? 7. What's my y1 value?
5.
5. So that's just going to be 7 minus 5. So right, it's 7 minus 5, which becomes a 2. That's called right there. That's called the change in your y values. Over here, what's my x2 value?
2 and 4.
2. What's my x1 value?
4.
4. That becomes 2 minus 4. 2 minus 4 is negative 2. That's my change in my x value. 2 divided by 2 is equal to negative 1. That is my first slope. That's the slope of this line. It means it goes down 1 unit and over positive 1 unit. That's what that slope will look like. Now we're going to do a graph here in just a second. Okay, we're going to do a graph of one. But right now, that's how you would do problem number 1. Okay, and you have it done in your journal. You don't have to recreate that on your paper. You can just write down the slope is what?
1.
No. Negative 1. There we go. Number 2. Put number 2 in your journal. I'll pause while you guys do it. First thing first, we're going to label x1, y1, x2, y2. And we're going to set everything up just like we did before. Our slope formula was always y2 minus y1 over x2 minus x1. Okay? So here we go. Let's go ahead and label organize our information. Y2 is 2. Y1 is a negative 4. What's going to happen with those negatives? That's going to become a 2 plus a 4, because a negative times a negative is a positive. That's why I want you guys to use parentheses. I want to make sure you guys see that when there's a negative and another negative, which makes it a positive. There we go. X2. 3. X1. Negative 2. Another, a negative and a negative make a, that becomes 3 plus 2. So 2 plus 4 is 6. 3 plus 2 is 5. What is our slope? 6 over 5. And I want you to leave it at 6 over 5. Quickly, what I want you guys to do now is follow me and do what I'm doing in your journal. Here we go. I want you to make an x-axis and the y-axis. I'm going to call 2 points. Point A and point B. Just so you guys know, point A is going to be negative 2, negative 4. Negative 2, negative 4. And point B is going to be 3, 2. The problem that we just did. So I'm going to go -2, -4. I'm going to put a point. I'm going to call it point A and label it -2, -4. I'm going to go over here. I'm going to go over 3 and up 2. I'm going to put another point right here. I'm going to call this point B, which is at 3, 2. Then I'm carefully going to construct a line. I'm going to construct a line that is going to go through those 2 points. All right, so right now, go ahead and construct this line, because what we're going to be talking about right now is showing you guys that it's so easy to find the rise and the run of a graph. If you're given a graph, I always loved interpreting slope on a graph, because I could always figure out how much it went up and how much it went over, or how much it went down and over, okay? But can everybody see how this goes up from left to right? This is definitely going to be a positive slope, everybody. It's going to be a positive slope line. What do we call when it goes up? We call that the rise. What do we call this section from left to right? We call that the run. You can clearly see it's going up, which is positive. We can clearly see that it's going to the right, which is also positive. How much does it go up? 1, 2, 3, 4, 5, 6. How much does it run? 1, 2, 3, 4, 5. It runs 5. By the way, when you're counting, make sure you count the spaces between the points. Check it out. 1 space, 2 space, 3 space, 4 space, 5 space, 6 space. Here, 1, 2, 3, 4, and there's a space right there. And how do we always interpret slope? From left to right, and we put the rise over the run. This is what I want in your journal, so that you guys can clearly see a nice, neat drawing of the graph going up 6 and over 5. There's the 6 over 5 that we got by doing the algebra, right? Actually, it's doing math. Okay? So make it nice, neat graph. And what do I want you guys to label? I want you guys to draw how much it goes up, and draw how much it goes what? To the right, over. There's the rise, there's the run. Okay? Alright, we're going to go ahead and do problem number 3 right here. We're going to do problem 3. Show you what happens. We have x1, y1, x2, y2. We're going to set it up once again the exact same way. y2, y1, x2, x1. Okay? My y2 is 2. My y1 is 2. Huh. You guys notice about my y values. They're the what? They're the exact same number. What's the difference between 2 and 2? 0. Okay, well, we have to check these out. x2 is a -3, x1 is a 5, -3 minus 5 more is a -8. But if you take that and put it in the calculator, you're still going to get 0. So this is a horizontal line. The equation of this line, what is my y value always going to be equal to on this line? Just a 2. What is your slope? Your slope is equal to 0. The equation of your line, the equation is y equals 2, but your slope is 0. This would be a horizontal line. Okay? This would be a horizontal line like this. That was the y-axis, and this was the x-axis. Where would it pass through? It would pass through right here where the y value is a 2. This would be the graph of your line, where y is a 2. That's a 1, that's a 2. Okay, one of them would be over here at 5, 2, and the other would be -3, 2. Alright, and then I would like you guys to do problem number 5, last one in your journal. Okay? So here we go. We're going to label x1, y1, x2, y2. Set up one more time. You guys should be getting used to labeling it now. It shouldn't be a mystery what we're doing. There's your slope. N is equal to this. What are we going to be finding? We're finding a change in the y over the what? Over the change in the x. Okay? Interesting. What do you guys notice about my x values? They're both the same. So, here, that cancels to a positive. Negative 3 plus 3 gets me to a 0. So even if I have negative 1 minus a 5, and I get a negative 6, so negative 1 minus 5 more gets me what happens when you get 0 in the denominator? That's where you get an undefined slope. What I need you guys to understand. When you get 0 in the numerator, but you get an integer in the denominator, your slope is 0. But if you get a 0 in the denominator, what is your slope going to be? Now, does anybody know, before you guys put up, before I let you guys leave, does anybody know what equation x will always equal in this vertical line? Nope. Nope. X is only going to equal one number. Nope.
What?
I'll give you a hint. It's highlighted.
Oh, -3.
Your x value is always going to equal -3, because that's what it's going to say in the vertical line. Well, have a good day.